Assalamu alaikum students. Today we solve exercise 3.4. Now in first question we have to show a plus b is symmetric, and first we find a plus b, then we take its transpose. If its transpose is equal to a plus b, then a plus b is symmetric, and transpose by converting rows into column. If the elements are same, then this matrix is called symmetric. Next we show A plus A transpose is symmetric. First we find A plus A transpose. A plus A transpose. By adding this, then we find its transpose. If the transpose is same, then this is called symmetric. And in second part we show that A minus A transpose is skew symmetric. We find A minus A transpose, then we again take its transpose, and because we show skew symmetric, at the end we common -1. Again it is equal to A minus A transpose, therefore A minus A transpose is skew symmetric. In this question we show that A plus A transpose is symmetric, where A is equal to matrix of order 3. In matrix of order 3, the elements are like A11, A12, A13. Order 3 means 3 rows, 3 column. And A21, 22, 23, and A31, 32, and 33. To show A plus A transpose is symmetric, by taking transpose on it, we apply in the bracket, and we get A transpose plus A transpose whole transpose. If we transpose a matrix 2 times, it become on the same condition. Here we have A minus A transpose, and here we show skew symmetric. We take transpose, A transpose minus A transpose, A transpose, and transpose A transpose minus A. To make it in same order, we take -1 common, and it is equal to the right hand side. Here we have matrix A and B are matrix, and given AB is equal to BA, we are to show that AB is symmetric. A is symmetric, therefore A transpose is equal to A. B transpose is equal to B because B is also symmetric, and AB equal to BA. 3 conditions are given. Now we show that AB transpose is equal to AB. We let left hand side AB transpose. When we transpose the product of two matrices, transpose on each matrix, and they change in their order. Because B transpose is equal to B, A transpose is equal to A, and BA is equal to AB. Therefore AB product is symmetric. In this question we show that A product A transpose and A transpose into A are symmetric for any matrix of order 2 cross 3. 2 cross 3 means 2 rows, 3 column. We apply transpose on left hand side, and again we know that if we transpose on the product, their orders change, and transpose on both matrix, and transpose cut by transpose. Therefore A transpose is equal to A, which is equal to right hand side. And same on the second case. Now question number 6. A is equal to iota 1 plus iota 1 minus iota. We show that A plus A bar transpose is Hermitian, and A minus A bar transpose is skew Hermitian. When we take A bar, negative sign with iota, we have A, and then we find A. First we find A bar. When we find A bar, the imaginary components sign is changed. Plus iota become minus iota, and minus iota become plus. Only imaginary numbers, not real. And then we take its transpose, and then we add A plus A bar transpose, and this is equal to this matrix. And this matrix we show that is Hermitian. We again take its bar and then its transpose, and which is equal to the same matrix. Therefore A plus A bar transpose is Hermitian. In second part we show that skew Hermitian. We first find A bar, then A bar transpose, and we show that A minus A bar transpose is Hermitian. We find A minus A bar and transpose, and then we show it skew Hermitian. We again take its bar and transpose, and then because it is skew, we minus 1 common from the matrix, which makes the sign change. Therefore A minus A bar transpose is Hermitian. In this question, A is symmetric or skew symmetric. Show that A square is symmetric. If A is symmetric, then A transpose is equal to A. Now to show A square is symmetric, A square transpose, A square means A dot A, and A transpose, because A is symmetric, therefore A transpose is equal to A, and A dot A is equal to A square, therefore A square is also symmetric. Now in case skew symmetric, A transpose is equal to minus A, and A square is symmetric, not skew symmetric. We show it symmetric. Now A square transpose equal to A transpose, because A is symmetric. Skew symmetric, it is equal to minus A, and product of minus A into minus A is A square. Here we have a matrix A. It is called column matrix because it contains only one column and 3 rows. We find A product A bar transpose. We first find A bar, we change the sign of imaginary number, and then we take its transpose, and it is row matrix. Now when we multiply these matrices, multiply row into column, first row contain one element and first column of the second matrix contain one element, and then we multiply 1 by 1 minus iota and 1 by minus iota. In same way we multiply second row with the next 3 columns and third row with the next 3 elements. This multiplication is very important. we get iota square, it is equal to -1. Now in this question we find inverse by using row and column method. First we find its inverse by adjoint method. We first find a determinant. Next is adjoint. Adjoint is cofactor. We find all cofactor and their transpose. A11 means we draw first row and first column and the remaining values in the determinant. And A12 means we draw first row and second column and remaining values in the matrix determinant. And same way we find other cofactors and we place their sign. We starting with plus, minus, plus, minus, plus, minus, plus, minus, and then we find their determinant by cross multiplication, and at the end we find their transpose. And then we divide adjoint of A with A determinant, and we are on the last condition, which is called inverse of A matrix. Here we have A, we find its determinant, it is not equal to 0, non-singular matrix. So we find inverse by row method. We have done in examples. We apply a new matrix with an identity of same order with the same matrix in same bracket, and then we convert the first 9 values in identity form by row method. First of all, we have in first column 1 0 1 and we make last one equal to 0 by subtracting it from the row 1. We subtract R3 minus R1 and the new values we arrange in the new matrix, and then on the second column here we have -1, we multiply it by -1, R2 multiply by -1 and it makes it 0 1. Now we make 2 and -2 equal to 0. To make 2 in first row equal to 0, we write R1 minus 2 R2, and to make -2 equal to 0, it is in R3. -2 means we arrange there +2 and R2. Why we write R2? Because in R2 we have 1. It makes both these values 0, and we arrange our second column. Now at the third column we have -3. We divide -3 by -3 and we get here 1, and next step we make 5 and -3 equal to 0. Now how we make 5 and -3 equal to 0? 5 in first row and -3 in second row. Second row plus 3 R3. R3 because in R3 we have 1, and -3 we write there +3, and +5 we write there -5. First row where we want to make 0, and last row where is 1. Now our first 9 values equal to identity and next 9 values are the inverse of A. Now we find inverse by column method. First we find its determinant. If the determinant is not equal to 0, then we proceed the next steps. Here we write the matrix below the original matrix, identity matrix, and we arrange row values. We have 1, -3 and 2. We make -3 0 with the help of 1 in first column, -3 in second column, and -3 we place there +3, and 2 in column 3 we write -2 and C1. We place the values and we have new values in new matrix, and we arrange our first row. Then we make in second row mid value is equal to 1. Here is 7. We divide it by 7. It makes 1 there, and then we make 2 and -4 equal to 0. 2 in first column and -4 in third column. With the help of 1 we make them 0, and 1 is in the second column. For 2 we write C1 -2 C2, and for -4 we write C3 +4 C2, and then we put the values and we get the answer, and our second row also complete in the form of identity. Now in third row we make 1, we divide by 7, multiply by 7 by 3 to C3, it makes it 1, and then we make 0 0 in place of 2/7 and -1/7. Difficult calculation, but try to do these and get the answer is equal to inverse. Now here we find rank. In rank we convert the matrix in lower diagonal values equal to 0, and here we have in first column with the same way as echelon method we do 1 2 1 3. We make these numbers equal to 0. 2 in R2, R2 minus 2 R1, 1 in third row, R3 minus R1, and 3 in fourth row, R4 minus 3 R1. Now we get the 0 0 0. Next, according to diagonal, we have 3, we make it 1. 1/3 we multiply with 1 by 3, we get 1 5 in second row, and then we make 2 and 5 equal to 0. 2 in second row, third row, and R3 minus 2 R2 because in R2 we have 1, and 5 in R4 minus 5 R2. Again we get all values equal to 0. We put these values. Non-zero rows are 2, and R3 and R4 are 0 rows. Therefore, rank is equal to non-zero rows. How many non-zero rows there are? 2. Therefore, rank is 2. Okay, student, try to solve these questions. If you have any problem, contact with me. Thank you for watching. Jazakallah. Assalamu alaikum.